path. Okay, let's discuss about class path. We have already seen path. Am I right? Did we discuss about path? Why path is required in our earlier sessions? Okay. Did not remember? Just if you go for my computer, right click, properties, in the environmental variables we have set an attribute named path. Why this path is required? To make the command executable files available throughout the operating system. Path is required to make the executable command files to be available throughout the operating system. What happens if you don't update path? What happens if you don't update path? Or if you don't create a path? We can use the commands only in the folder of installation. If you don't update path, what happens is we can use the commands only where the commands are present. Let's consider like we have updated the path with ejdk 1.5 bin. If you don't update the path, what happens means just those commands will be available only to that location. So if you don't update the path, what happens? The JavaC, Java, Javadoc, JavaP, all the commands will be available only to this folder. Now let me remove the path. I am removing the path. Okay. Now let me try to compile the application. Let me see whether the path is available here or not. Is JavaC available? No. Why? Because by default commands will be available only to the folder where the exe files are present, where the command related files are present. So if you go for jdk bin, now is JavaC available? Yes, if this message comes, if the options comes means then the command is available. So now we need to update the path to make this command exe files available throughout the operating system. So we'll update the path. How we can update the path means just go for my computer, right click, we have properties. On my computer if we right click we have properties. In the properties go for advanced system settings. Just go for my computer. On my computer if you right click you will find properties, the last option. Go for properties. In the properties we have advanced system settings. Click on that, you will find a tab advanced. In the advanced tab you will find environmental variables. Basically there are two types of environmental variables. One is system environmental variables and the second one is user environmental variables. Now is it possible to have multiple users for the same system? There is a computer, is it possible to have multiple users for the same computer? Yes, it's possible to have multiple users for the same computer, for the same system. Okay. Now system environmental variables are generic to all the users of the system. System environmental variables are generic to all the users of the system. And system environmental variables can be updated only by administrators. The system environmental variables are available for all the users of the system. At the same time, they can be updated only by administrators, those who have administrator privileges. And this user environmental variables, see, user variables for something, some user. It tells the user variables for, this is the user, SARATH for you. So these user environmental variables are specific to the user who has logged in. User environmental variables are specific to the user who has logged in. User environmental variables are specific to the user who has logged in. So now if you want to make the commands available throughout the operating system, then we should set that location as the path. Now let's set the location as the path here. Okay. Now path can be set as a user environmental variable as well as a system environmental variable. Okay. Now in the development environment, the environmental variables will be set by using user, just because a developer, each and every developer will have his own credential, his own settings. The same system might be used by 10 developers, but each and every developer should have his own settings. So in general we go for user environmental variables as in the development environment. Go for path, phase location. Okay, and multiple paths are separated by semicolon. The delimiter between multiple paths is semicolon. So whenever you place a path, just place semicolon. Okay. 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 Now let us see. Go for E drive, or let's go for D drive. D is not available. Let's go for C drive. Okay. Now let us see. Is JavaC available? It's caps. Is JavaC available? No. Just because whenever we update the environmental variable settings, the settings will be available only for the new command window. Okay. So if I open a new command window, now is JavaC available in the new command window? Yes. Just because we have set the environmental variable, and if we modify the environmental variable, the changes will be reflected only in a new command prompt. Understood? This is path, and this is how we can set the path. And what is class path? That we'll discuss later. We'll see what is the disadvantages if you don't set the class path. What problems we face if you don't set the class path. Then we'll see how we can set the path, how we can set the class path. Okay, and how class path solves the problems. Okay. Now let me create. We have HU apps. Okay. We have exceptions. Let me have a class wrapper demo. Okay, in this there is a class wrapper demo. Now I want to make use of this wrapper demo class in some other place. What is the current one? Develop. I want to make use of. Let me write a main method. In that main method, I want to make use of Can I call the main method like this by sending null? Can I call this main method by sending null? Yes or no? Can I call the main method by sending null? Yes or no? Definitely yes. Just because even a string array, main method will take a string array. Even a string array will be considered to be an object. Even array is an object in Java. So for any object, it is a derived data type. And for any derived data type, we can send null. Okay, for any array, we can send null as a value. Okay? Now it is a string array. For string array also, we can send null as a value. Now let me try to compile this. Let me close this. Open a new command window. Now is it compiled? No. Why? Because it tells that wrapper demo is a class that I could not able to identify. So let us see what is the package structure of wrapper demo. What's the package structure? It's wrapper.demo. So first let us import that. Okay. So is it finding that? Is it finding that? No. Okay, but does that actually exist? We see here where it is wrapper classes. The classes. Is the .class file exist? Is the same package structure com.hu wrapper demo? Yes. But why it could not able to find that? Why it could not able to find that? Just because it is not in the current root. By default, it will search for that class. Okay? By default, it will search for the .class file in the current location where we are pasting the .class files. Now, where we are generating the .class files? Where we are generating the .class files? Where we are generating the .class files? Classes folder. Okay? Sorry, not at that place. It will look for the .class file in the current location. In the current location. In the current directory structure. I told very long back that folder should be called as directory in software applications. Okay, by default, a class will be verified in the current directory structure. But does that exist in the current directory structure? See, we are compiling from SRC. Okay, it will search inside the current directory structure. It will search for that class in the current directory structure. But does that class exist in the current directory structure? No, it exists in some other folder. Now, this wrapper classes SRC exists in some other folder, and the thing that we are compiling. These two, if you compare these two exist in completely different folder structures. It is in Javadoc, but this is in wrapper classes. So this will become third party to this, and this will become third party to this. It doesn't know, just because it is not in the current directory structure. Understood? We are in SRC. From SRC, okay, in the package structures of SRC, that doesn't exist. that class doesn't exist. Wrapper demo doesn't exist. So what happens? It will tell that I could not able to find the symbol. So it will become this. The classes present in Java.doc folder will become third party to wrapper classes. The classes present in wrapper classes will become third party to Java.doc. So what we need to do if we want to access these third party classes means we should update the class path. Okay. So now how we can update the, understood? What is the use of class path? If you want to make use of third party classes, what are the third party classes? All the classes that are not available in the current directory, current root directory. If you want to access the third party classes, but what are the third party classes means? The classes that doesn't exist in the current root directory are called as third party classes. So if you want to access the third party classes, we should update the class path. If you want to access the third party classes that doesn't exist in the current root directory, if you want to access third party classes that doesn't exist in the current root directory, we should update the class path. Now, is wrapper demo a third party to Java.doc? Yes. So we should update the class path of Java.doc with wrapper demo. Now, there are multiple ways of updating the class path. One of the ways that we can update the class path is at the command line. While executing the command itself, we can update the class path. Let us see how we can update the class path while executing the command. Okay? Now, understood? Now, there is an option -class path. Like -d, there is an option -class path. Okay. Now to the class path we will give the value where exactly the classes exist. Okay. Where exactly the classes exist? The classes folder. Okay. All the classes exist. All the classes exist in this folder. Am I right? So this I am updating the class path with this location. For -class path I have given the value. Okay. This is the path where the classes exist. And for -d I am giving the value .s classes. Just now, is it an absolute path or a relative path? If we give the path along with the drive name, then it is said to be an absolute path. That we have discussed already. If we give the path along with the drive, then it will be an absolute path. So, now let me try to compile this. Now is it compiled? Yes or no? Yes. Now, if I remove the class path, if I do the same compilation without the class path, is it compiled? Is it compiled? No. But if I compile the same thing with the class path, is it compiled? Yes. Just because we are telling where exactly the third party classes are there. We are telling where exactly the third party classes are. So it was perfectly compiled. So, understood what class path will do? Class path will be used to access the third party classes or the third party .class files. Class path will be used to access the third party .class files. And one of the ways of configuring the class path is while executing the command. While executing the command, we can set the class path by using the option -class path. We can use the option -class path as well as there is another option -cp. Either we can use -class path or simply we can use an option -cp. Both will do the same. Both options will do the same, -cp or -class path. No, the access level rules are different. The access levels rules are different and class path is different. Even we update the class path, if it is not in the current package, definitely we should import. The rules of access levels should not be combined with the class path. See, if it is in the current directory structure, we need not update the class path at all. Even if it is in the current directory structure, if it is in different package, whether we update the class path or not, we should give the import. Understood? Import is completely different. Whenever we access a entity which is other than the current package, then we should import. Whenever we use a third party which is not in the current root directory, then we should update the class path. It's completely different concepts. We should not club package import and this one, what we call class path. It resembles similar, but it's completely different. See, that is at the code level, at the package level. If we cross the package, we should import, whether it is present in the current root directory or it is present in the class path. It's irrespective. If it is other package, we should import. But what class path is? If it is not in the current root directory, then to access those third-party classes, we update the class path. Okay? It doesn't mean that if it is in the current root directory, if we update the class path, we need not import that. It's not like that. Whether we get the class from the class path or from the current root directory. Whether we get the class from the class path or from the current root directory. If it is in other package, we should import that. Understood? Now, let me go to the classes. Now, let's see wrapper demo has any compile time errors. Let me compile once again. Just I'll put system dot okay. Let me go to SRC. Let me try to compile once again. Let me try to execute the application. What's the class name? Java doc demo. Well, what is the exception or what is the error that is giving at the runtime? Class not found? Class not found is not an error, it is an exception. What is the error now it is displayed? No class, definition found, error. When a no class definition found error will be erased? When a no class definition found error will be erased? No. When we are trying to access some .class file, but it doesn't exist. We try to access some .class file, but it doesn't exist in the current folder. Okay? When we try to access some .class file, but it doesn't exist in the current folder, then it gives a no class definition found error. But could we be able to compile this application? Yes or no? Yes. But why at the runtime we could not able to find a .class file? What's the difference? See, we could be able to compile the application very successful, but we could not able to execute the application. At the time of execution, what it is telling me that it could not able to find the .class file wrapper demo. If it could not able to find the .class file, how it compiled? We are using, while compiling, what we have done? We have used the attribute class path. Even while execution also, the class path that is updated at the time of compilation will not be available at the time of execution. Just because the class path setting is at the command level. We have done the class path setting at the command level. That setting will be flushed out when the command execution is completed. Understood? The class path setting was done at the command level. So, how we can do the class path setting at the command level means go for option -C and the location where the .class files exist. Okay? And at the command level, if we update the class path means that class path will be valid only up to the command execution, not the next command. See, now let me go to the SRC. Now let me execute the let me compile the application. Now it will be compiled. Now again let me compile the application without using the class path. Is it compiled? No. Just because there might be a question like previously I have updated the class path. Why it is not fetching that in the next execution? Why it is not fetching this class path in the next execution? Understood my question? See, let me come once again. Now it is like this. I have compiled the application, and while compiling the application I have updated the class path. Okay? And I'll compile the application once again. Why that class path setting? Why this class path setting is not available to this execution? Because this class path setting is a command level. The command level class path setting will be flushed out when the command execution is completed. For the next command, again we should do the class path setting. Understood? So it will be like that. And let me try to compile using the class path setting. Now it was compiled successful. Now let me go to the classes. Now if we execute this application, will it be executed successful? Will it be executed successful? Just because we are using wrapper demo, but is it available? What it is telling? No class definition found error. While execution, when a no class definition found error will arise means when the runtime environment could not able to find the corresponding .class file. Why it is not available for the runtime environment? Why it is available for the compiler? At the time of compilation, we updated the class path at the command level. So now even at the time of execution also, we should update the class path at the command level. Now let me do the same thing. Okay? Understood? Understood? Now, let us see, will it be executed successful or not? Okay? Now, will it be executed successful? I have updated the class path and I am executing the Javadoc demo. Now, in the Javadoc demo, is there main method? Yes or no? Yes. That is calling the main method of the wrapper demo. And in the main method, just we are printing some message. Now, will it be executed successful? Will it be executed successful or not? Yes or no? Now, what is telling? Please wait for some time. What is it telling? What is it telling? Just read out the whole error. What is it telling? No class definition found error. com.hcu.doc.demo.java.demo. It is telling that in the current location it could not able to find that. But is it true? What is the current location? Javadoc classes com hcu doc demo java.demo. But why it could not able to find? It's telling that I could not able to find the dot class file com hcu doc demo java.demo. But why it could not able to find the dot class file? Just because while compilation, okay, the javac command will look in the current root directory as well as the class path. Understood? The javac command will look in the current root directory first, then the class path. But the Java command will look only in the class path. The Java command will look only in the class path. By default, the class path will be set to the current root. By default, the class path will be set to the current directory. But what we are doing? We are overriding the class path so that we are setting the class path to classes. Understood? The javac command, first it will look in the current root directory, then after it will look for the .class file in the class path. That's with the javac command. But Java command, what it will do? It will look for the .class file only in the class path. The Java command will look the .class file only in the class path. And by default, the class path will set to the current root, current directory, current folder. By default, the class path will be set to the current folder. But what we are doing at the time of execution? We are setting the class path. We are overriding the class path to HCU wrapper classes. Now, in that folder, do we have in the HCU wrapper classes? Do we have this structure? Do we have this structure? In this location, do we have this class? In this location, EHU wrapper classes folder, do we have this class? No. That's what it is looking for. The Java command will look for the .class file only in the class path. By default, the class path will be set to the current folder or current directory. But here through the -cp option, we are overriding the class path so that it should look in the classes folder of the wrapper classes. But in the classes folder of the wrapper classes, Java doc demo doesn't exist. Understood? That's the problem. So while updating the class path, we should take care that we append even the current directory also. While updating the class path, it's very important, very common mistake. Many people will not append the current root directory, But while updating the class path, it's must and should, we should append the current directory also. But how we can represent the current directory? We can make any directory as a current directory. But to represent the current directory, there is dot. Dot will represent the current directory. So between multiple dot is one path and E wrapper classes in another path. Between multiple paths, the delimiter is semicolon. Understood? Now it will be compiled successfully. So it's calling the wrapper classes, but we did not compile the wrapper class, so it was going for the existing application only. So now it is coming here, okay, and it is calling test1 of the second method, the second test1 method. Anyhow, it is executing the wrapper demo class. Understood? How Classpath will make the difference? But a very common mistake is we will forget to append the current directory while updating the class path. It will lead to very massive errors. But we cannot figure it out very easily. If you miss out the current directory, we go on researching why it is a problem, why it is a problem, why it is not able to find the current .class file, even if it exists. Just a simple mistake you have done is you did not append to the current directory. Whenever you use the class path, make it a habit that first verify whether current directory dot is there in the class path or not. Whenever you use the class path should contain dot. Make it a habit. Understood? Otherwise it will give unexpected results. Dot represent look even in the current directory. Understood? And if you want to give another path after dot, just consider like semicolon. Okay, one path, semicolon, another path, dot is also considered to be one path. Semicolon. Let's go for some other folder structure. Okay, semicolon. Like this, between multiple paths, this is one path. This dot is one path and string classes is another path. Between multiple paths, the delimiter is semicolon. Understood? And this is called as an absolute path, just because we are giving it along with the drive name. Okay? Now, what is this path? Dot dash classes. We are giving dot has classes. What is this type? What is this type of path? It's called as a relative path. Okay? By referring to the current location, we are going one step back, and that folder we are looking for classes. This is a relative path. If you take current directory as a reference, then it is a relative path. If you give the whole drive structure, then it is a absolute path. Understood? Why and how the class path will be important? Now, this is class path setting at the command line level. At the command level, we can set the class path even to be applicable to the whole command prompt. We can make the class path to be applicable to the whole command window. Whatever the command that we execute in the command window, the class path will be applied. Okay. Now, how we can set a class path at the command level, at the command prompt level or at the command window level, means using a command set in single quotes dot semicolon like this. Set space, the attribute name equal to, in single quotes, the value. Set space class path equal to something. Set space path equal to something, like that. Now, if you set the class path, from that point, the class path will be available throughout the command prompt. Whatever the commands that we execute in the command prompt, the class path will be available. This is the class path setting at the command window level or at the command prompt level.
Example in your Java application, something logs you can then set the path at last. Otherwise, you if you set the path, you will do.
Perfect. Only class path is required. But if we are using any commands of that software, understood? If we are using any commands of that software, then we should set the path. Path is used only for commands, to make the commands available. Let's consider like, do you know web applications in Java? Do you know Tomcat? Tomcat server. In the Tomcat server, to start the server, what we have a command startup. To shut down the server, we have shutdown. Those two are commands. Tomcat is external software, it is not in Java. So, if you want to make use of the Tomcat, what we need to do? We need to start a Tomcat server. But the startup and shutdown commands will be available only to the particular folder inside the Tomcat. So, if you want to make them available, then we should update the path. But if you want to make use of the classes that are present in the Tomcat server, then we should update the class path. Okay, path is used for commands. Okay, class path is used for .class files. If the software will give you only .class files, then what do you need to update the class path? The software gives you commands as well as .class files. For commands you update the path. For .class files you update the class path. Understood? Now I am setting the class path to be available throughout the command prompt. Now it is set. Now, if we execute the application, will it be executed successful?
Yes, sir.
Yes or no? Yes. Why it is not set? Just to find the value of a specific attribute, just go for echo space. Sorry, it's my mistake on my side. You should not give in single quotes, we should give it directly. Just modify this. We should not give in single quotes. The attribute name equal to value, that's it. Set space, the attribute name equal to attribute value. No single quotes. Now it will set the class path directly, and if you want to find what is the value of a specific attribute, just echo space percentage attribute. In the percentages we should give the attribute name. Is it not visible? Is it not visible for you? Is it visible or not? Yes. So what we need to do is just go for echo space percentage attribute name percentage. It will give the value. Now let me go for echo percentage. It gives the value of the path. Okay, like that. Okay, if you want to find the value of any attribute, just go for echo space percentage attribute name percentage. Now we have set the class path to be available throughout the command window. So this will be execute application, it will be executed directly. Now let me go to SRC. Now will it be compiled? If we compile like this, sorry. If I compile the application like this, will it be compiled? See, we are using a third party class. We are using a third party class wrapper demo. But while using the JavaC command, earlier we have used like this. Okay? Earlier we have used like this so that it was compiled. -cp some wrapper classes so that it was compiled successful. But now what I want to do is I want to compile like this. If I compile like this now, will it be compiled successful? If I compile using this command now, will it be compiled successful or not? Yes or no? Yes, definitely yes. Was it compiled earlier? No, just because now why it is compiling means we have updated the class path to be available throughout the command prompt. Now let me open a new command prompt. Let me execute the same thing. A new command prompt. Is it compiled? No, just because the class path setting that we have done at the command prompt level will be available only to that command prompt. The setting that we have done at the command level will be available only to that command. Okay, so for the new command prompt, it's not available. So to overcome this problem, we update the class path as a environmental variable so that it will be available throughout the operating system. Understood? So let me update the class path in the environmental variables. Okay, already there is a class path e lib. So what I have done? First I have pasted the tomcat jar file. Okay, semicolon dot semicolon. Already dot is there, so we need not to go for dot again. So let me give this. Okay. After pasting any path, paste semicolon. That would be a better way. Okay? Okay? That's fine now. Now the class path is updated in the environmental variables with e wrapper classes. Okay? Now in this command window, now will it be compiled successful? We have updated class path in the environmental variables. If you updated the class path in the environmental variables, will it be available here or will it be compiled now? We tried here, it will not be compiled even, just because the changes done in environmental variables will be updated only in the new command window. Now let me open another command window. Now let me use the same thing. Was it compiled? just because the class path was updated with them. Understood? It's how the class path works. Okay, if we want to access any third-party classes, now it is a third-party class in our application, in our in our system. Let's consider like there are multiple third-party softwares like Hibernate, Spring, and JUnit. How they provide their entities to us. Let's consider like simple example, Hibernate. Okay, it's used to interact with the database. That we'll discuss later on. Hibernate is a third-party software. What Hibernate developers will do means, okay, they'll give the software to us, and we should use that software. But how we can make use of the software? That software contains all the entities, classes, interfaces, enums, annotations developed by Hibernate developers. But you should use the software. Okay? Then you should update those .class files in your class path. But those .class files will not be provided. There will be thousands of .class files. Okay? So they will not be providing as folders. They will not be providing individually. What they will do is they will provide the .class files, okay, as a bunch, okay, as a group by using a jar file. Okay, any third-party jar file, any third-party classes, any third-party entities will be provided as a jar file. What we need to do is we need to update the jar file in the class path. We need to update the jar file in the class path. Okay, now let us see how we can create a jar file, a third-party jar file that we can use in a class path, and then after we will see how we can use that in our class path. Okay, understood? Now let's see one third-party jar file. Now itself we have seen some third-party jar file which is Tomcat related. Now itself we have seen one Tomcat 6.0 the lib. Okay, there is the third-party jar file servlet-api.jar. If we open the servlet-api.jar, we will find all the entities that are present in servlet-api.jar. Okay, the JavaX servlet, okay, servlet.class. Now let me import this. Now, do we have this servlet-api.jar in our class path? Let us see. We go to the class path, environmental variables. Do we have the servlet-api.jar in our class path? Yes or no? Yes. So, since it is there in our class path, we can directly use the entities present in the jar file. What is the package? It says javax.servlet.servlet. So let me import that in our class. Import javax.servlet. Okay. Now let us see, will it be compiled or not? Was it compiled? Was it in our application directory? No, it was not in our application directory, but it is there in the class path that we have updated. So all the third-party classes will be provided as a bunch, as a group through jar files. But let's consider like I have developed a software. Let's consider like I have developed a software. Then how I can expose my entities as jar files? Okay, is there a way to expose my entities as a jar file? Yes, we can do that using Java commands. Okay, how we can do that? That we'll see. Understood? See, rather than providing the folders and folders and folders, we will provide all the entities together as a jar file. Okay? So already we have seen some third-party jar files which are provided by Tomcat. Now we will see how we can create a jar file so that we can sell our jar file. Okay, we can sell our software product as a jar file. Now, to create a jar file, there is a command in Java which is jar. Now, let's do the same thing. Let's not update this. Let's not update this in the class path. Let's update this as a jar file. Let's provide this as a jar file. Now, previously what I have done is directly I was providing the classes folder, but it's not advisable to give folders, to expose the folders. So what I'll do is I'll remove the folder so that now classes doesn't exist in the wrapper demo, doesn't exist in the class path. Now let me make this wrapper demo as a jar file, and let me update the class path with that jar file. Okay, now let me go to this wrapper demo. Jar file should be made only from the classes, not from the SRC. Okay, now let me close all the things. Now, how we can create a jar file means, okay, just go to the classes, okay, go to the classes folder, okay, and execute the jar command. The jar command has two mandatory options, C and F. Jar command has two mandatory options, C and F. C tells create a jar file. C tells to the jar command that we should create a jar file. F tells the location of the jar file to be created, or the location in which the jar file to be created. C triggers or C tells or triggers the jar command to create a jar file. The option C triggers the jar command to create a jar file. F option tells in which location the created jar file should be. And the general convention is all the jar files should be in a location in a folder structure lib. Okay, SRC for source, classes for .class files, docs for documents, lib for jar files. That's the standard convention. That's the industry standard. SRC for source files, .java files, classes for .class files, docs, DOCS, docs folder for documents, and lib folder for libraries. Libraries means jar files. It's a standard industry convention. Okay, now I'll tell to the jar command that please generate a jar file and put the generated jar file in specific location. What is the location? Lib. Can we make like this? Can you put like this? /lib. Now we are in classes. Can we give /lib? Yes or no? See, what is dot mean? Now we are in classes. Will get to the one step back. Inside that folder, do we have lib? Yes. So it will be valid. Now at the end we should give star. That means generate executable jar file with all the files in that location. Any file name with any extension. Okay? Now, let's try to generate the jar file. Sorry? Sorry? We should specify even the jar file name also. While creating the jar file, we should specify even the name of the jar file. Just star is enough. Star dot, we can be, even if we give star dot star, it doesn't make any difference. But star is enough. Okay? Just to generate a jar file, go for jar space -cf option. C tells or C triggers the jar command to create a jar file. F will take the location and the name of the jar file. F will take the location and name of the jar file. At the end we should give star, means the whole content of this folder to a jar file. Now if we execute this command, now if you see in the lib, test.jar is created. Now if you see, if you open, all of you know about WinRAR, right? WinZip, WinRAR, all of you know, right? Is there anybody without knowledge of WinRAR? Is there anybody here without the knowledge of WinRAR? No? That's fine. Now just I'll extract here. Okay? All the contents, if you have 100 classes, all the 100 classes will be there in the jar file. Okay? Now, if you generate a jar file, in that automatically a meta-nf folder will be generated. What is meta? Meta means extra information. Information about the jar file. And the manifest file will be there. Okay? Just we will have manifest person and who has created the jar file. The jar file has been created through jar command. Jar command means Java software. So it's telling that created by something. Understood? It has some meta information. Okay? What is the version and what is the who has created this jar file? This jar file has been created through jar command. That means through Java software. So it has given so that 1.5.0_11 it's by Sun Microsystems. Just manifest file contains the additional information, the meta information about the jar file created. The manifest file contains the meta information about the jar file that we created. See, if in the jar file, in the lib, if you see here, we have created the jar file. When I have extracted the jar file, okay, the actual content will be there. Along with the actual content, the meta-nf file will be there for any jar file. For any jar file, this meta-nf file will be there. The meta-nf folder will be created. The meta-nf folder will contains the meta information about the jar file, and this meta-nf will contain a manifest file. this manifest file actually contains the meta information. For any jar file, this meta.inf folder will be there, will be automatically created. Understand? Now this contains the meta information. This manifest file, this is called as a manifest file. Inside meta.inf, we have a file, manifest.mf. Okay, this will be created for any jar file. This is called as a manifest file. Okay, and this manifest file contains the meta information about the jar file. When it has, who has created that, when it was created, depends upon our settings. Okay, understand? Are you getting, or are we going a little bit fast? Is it okay? At the starting of my career, to be frank, even I don't know what is WinRAR. So you guys are fast forward than me. Sometimes it happens like that. And to be frank, even up to BTech 4th year, for the first time I came to Hyderabad in my 4th year, final year of BTech. Up to that time, even I don't know what is a pen drive. I thought that pen drive will be like in a pen format. It will be like that, but yes, effort will make anybody better. And it's not exaggeration. I think that I was one of the best examples for that. Okay, that's why I used to ask you, put the effort. Whether you have talent or not, that is irrespective. Definitely effort will make you better. So now we have the jar file, and inside the jar file we have the manifest information. Now let me use this jar file. Okay, let me update the class path with this jar file. Okay, copy this location and update the class path. Okay, now I have updated the class path with the jar file that we have created. Okay, now let me open a new command prompt. And let me try to compile the application. Sorry, go for location. What is location? See apps. And let me try to compile the application. Was it compiled? Yes. Now, did we update the class path using the folder structures? Did we update the class path using the folder structure, or did we update the class path using an executable jar file? Sorry, it's not executable jar file. We have updated the class path using a jar file. This is how we can expose our software as products. You develop a new software, you won't carry all the formulas with you. Just you create simple jar file and tell that all my development is there in jar file. So what you will do, you will update, a new person will update his class path with the jar file and will use of your application. Understood? And it might be a single jar file, might be set of jar files based on the requirement. Okay? In general, it will not be a single jar file, it will be a set of jar files. A group will be in jar file, another group will be another jar file, another group will be another jar file, like that. Okay? It might be based on the requirement, based on the size of the project. It might be in a single jar file, or based on the requirement. If it wants to be, or if it is supposed to be modularized, they will distribute into multiple jar files, and they will distribute the jar files as a zip, and extract the zip, take the jar files, keep it in the class path, and use the software. Okay, this is how we can use any third-party software. If I give any third-party software, just extract the zip, go for the lib folder, get all the jar files, put in your class path. Just that's it. You can use the third-party software. Understood? Understood? Now, the next concept in jar files is a executable jar file. How we can make a executable jar file? Creating a jar file or executable jar file is, the process is almost the same. We use the same jar command. Okay, but we use another attribute, m. Use another attribute, m. The full form of m is manifest. M means manifest. What is the information that we need to put in the manifest file? So let me copy the existing manifest file from existing jar files rather than creating it again. See, this is a manifest file, right? So let me copy this, then we create another file. Already there are two. Okay, now let me create another one. Okay, to create an executable jar file, we should have a manifest file. We should have a customized manifest file, rather than depending upon the manifest file that is created by the jar command. By default, this manifest file will be created by the jar command. But if you want to make that jar file as an executable jar file, we should override the manifest file. So rather than depending upon the jar command to create a manifest file, we will give the content. What should be the content of the manifest file? Okay. So now the manifest file will give. To create executable jar file, first we should have the content of the manifest file. We should override the content of the manifest file. So the manifest file, first one attribute is manifest version, second is created by. Okay. In the manifest file, the attributes should be in this way. The manifest attributes. Okay, manifest version is one attribute, created by is one attribute, main class is one attribute. Okay, the manifest attributes will be in such a way that there should be multiple words should be in upper cases. Okay, if there are any words, any number of words, all the words should start with uppercase. If there are 10 words or 20 words, all the words should start with uppercase. And each and every word should be delimited by hyphen. So main hyphen class, created hyphen by, manifest hyphen version. Like that, M is capital, C is capital, just because those two are different words. And main and class are separated by hyphen. Main and class are separated by hyphen. And soon after the manifest attribute name, we should give a semicolon, sorry, colon. Just after the manifest attribute name, we should give a colon. And after colon, we should give a space. After colon, we should give a space. And after space, we can give the manifest attributes value. Now, if you want to give a class, now if you want to go for executable jar file, what is the executable jar file means? We can directly execute the jar file. See, in general, we will execute a class, but we can directly execute a jar file. But a jar file may contain hundreds of classes. With which class the execution should be started means that will be specified in the main class attribute. See, the jar file may contain hundreds of classes, but if you want to execute the jar file, there should be a starting point from where the execution should be started. That class will be specified in the manifest file as a main class, and the value will be the class along with the package structure, the class that we want to start the execution. The jar file may contain any number of classes, but the execution will start with the main class that we have configured in the manifest file. So the attribute will be, let me reiterate the rules. The first thing is the attribute name colon attribute value syntax. Okay, the attribute name may have a single word or even multiple words. All the words should start with uppercase. There are multiple words, the multiple words should be separated by hyphen. After the attribute name, there should be a colon. After the colon, there should be a space. And after the space, we can give the value of the attribute, value of the manifest attribute. And at the end of the manifest attribute, we should go for enter, a new line character. If you don't go for enter, then it will not work. So, at the end of any manifest attribute, it should be a new line character. Enter, go for enter. Understood? Or do you have to tell once again? First, manifest attribute which may contain multiple words. All the words should be started with upper cases. Words should be separated or delimited by hyphens. After the attribute name, colon. After colon, space. After colon and space, just give the value of the manifest attribute. And at the end of the manifest attribute, just give enter, so that it will be a new line character. So let me say this manifest attribute. The classes. Let me store it as mf.txt. Okay? Let me store it as, in the classes I am storing it as mf.txt. Okay? Now, how I can give that? Please go for this manifest attribute, or please go for this manifest file to define the meta-nf. So, in the jar file we have meta-nf. Okay? In the jar file we have meta-nf. In the meta-nf we have manifest.mf, which has the meta information about the jar file. So, now we are not depending upon the jar. We are not depending upon the jar command to create the meta information. We ourselves are creating the meta information. So, now let me delete the existing jar file, or let me keep it like this so that we can observe the differences. Okay? So, now what I'll do is, I'll create a jar file. -c will tell that create a jar file. F will tell that the location of the file. M will tell that the manifest file location. Okay? The manifest file is in the same location. So directly we'll give if it is in some other location, we'll give the path. If it is in the same location, we'll directly give the file name. Understood? If it is in some other location, we'll give the path. If it is in the same location, directly we'll give the file name. So for f, the value is // let me make it HCU.jar. Understand? For f, for C we need not to provide any value. For f we are providing the value that the location and the jar file name. For M is the manifest information. We are providing the file in which the manifest information is there. We are providing the file in which the manifest information is there. Over? Now let us see. We have created a HCU.jar. So let me extract this. Is it here? HCU. So whatever we have given, that has come to the manifest file, manifest.mf of the HCU.jar. Okay, whatever we have given, that has come here. Okay, so here like this we can go for customized manifest information. Okay, now if you want to execute this jar file, let me go for lib. You want to execute the jar file, just go for Java command, the option -jar, just to execute a Java application, go for Java command. If you want to execute a executable jar file, go for the option -jar and the name of the jar file. Java space -jar is the option and the jar file name. What is the name of the jar file? Now we are there in the lib. Okay, so it is executing the jar file. So it is executing the main method of the wrapper demo. Understood? This is how we can create executable jar files. Why these executable jar files are required means, okay, if you want to expose our product as a desktop product, now there will be several desktop applications. Now if you see, whenever we go for a setup file, let's consider like Java application. Okay, Java application, whenever double click on the Java software, it will open the wizard. Next, next, and next. How these things will be done? How these things will be initiated means, internally with that Java software, they will provide a internally. Whenever we double click on that, they will have a what we call executable jar file. In the background, they will have a executable jar file. That executable jar file will be running, but that icon, if you see this, where it is Sharat? Where the Java software is? Software, tutorial softwares. See, here we have, where it is? No issues. We have a tomcat.exe. We have executable file. This is a setup file, but this is just a sugar coating for the executable jar file. This is a kind of sugar coating for the executable jar file. Internally, it has a executable jar file. So when we double click on the exe, okay, internally executable jar file will be executed, and this will be displayed. And this will be done by some desktop, like desktop development tools, desktop application development tools. In Java, we have AWT, applets, Swing. Using those kind of technologies, they will develop this windows and all, and they will apply some business logic in this windows and all. But what we are exposing? We are exposing an executable jar file. We are exposing the executable jar file as a exe file. Understood? That's how the executable jar files will be used. In general, in most of the cases, if we have a desktop Java application, means when we click on the exe file, it will execute the executable jar file internally. This exe file is just a kind of sugar coating to the executable jar file. Okay? Whenever you want to, anybody asks you to develop a software application, what you do means you develop a software application, develop an executable jar file, and there are several tools which where we can create a exe file from an executable jar file. Like there is a tool, I think JEXE Creator. It is an open source tool. What it will do means it will take a executable jar file, JEXE Creator. It will take a executable jar file as an input, and it will provide you the exe file. So whenever we double click on the exe file, internally in the background it will execute the executable jar file. So there are several. I am telling only the example. If you search in the Google for like just search create exe file from executable jar file, we will find several softwares. Okay? Otherwise, just type like this, you will find several software. One among the software is JEXE Creator. You can find any of the software. If you feel that any of the software is better, then you can use the software. Any of the software that creates a exe file from a executable jar file, what it will do means it will take the input as a executable jar file and it will give the output as a exe file. So when we double click on the exe file, in the background the executable jar file will be executed. Understood? That's how we sell the desktop products in Java. Understood? That's how it will be, and this will be the end of this session. And the only concept that we have in core Java is file handling. Okay, that will start fresh in tomorrow. Okay, and tomorrow morning or evening? Morning? You come in morning, we come in evening. So evening.